Hello, grade 12s. Welcome back to the review of Mathematics Paper 1, November 2023. Now let's go into question 3. Okay. So now here we're given a geometric series, 3 plus 6 plus 12 up to n terms. Okay. And the first thing that they want from us there is write down the general term of this series right here. So they don't want the sum, rather they want the general term. Okay. So we know that anytime we're talking about the general term, we must think in terms of the pattern itself. Okay. So we know that Tn is equals to ARn to the power -1, n minus 1, like that. Okay. So now the question is, what is the value of R? Which could be easily found by saying T2 over T1. In this case, we have 6 over 3, which should give you your 2 there. And the value of A is the value that you're given there at the beginning. It's the first term. So in this case, Tn is equals to 3 times 2 to the power n minus 1, like that, right? And that would be the pattern there, okay? Or the general term of the series. Now let's go into 3.1.2. Now they want us to calculate the value of k such that that is true, like that. Okay. So now, whenever you're dealing with sigma notation like that, you first have to find the number of terms. So for us to get the number of terms, which is n, we'll say that we have top number, right? Top number minus the bottom number, and we add 1 to it. So now in this case, k is our top number. So k is our top number. And we're going to minus the bottom number, which is, in this case, bottom number is p, which is equals to 1. And we have a plus 1, like that. So this means that n is equals to k. N is equal to k. So there are cases where k is just treated as the top number, and it is part of the calculation when you're looking for the number of terms. And there are cases where k is the number of terms. So when will k represent the number of terms? If and only if the bottom number is equal to 1. If you have any other value, other than 1 here, then k is to be treated as the top number, and you will use this formula here to obtain the number of terms that you're adding up together for your sigma, like that. Okay. So now we know that this is a geometric series. So we're going to use the formula as such. So we're going to have Sn is equals to A into R to the power n over R minus 1. Well, I'm choosing this formula here because our R is greater than 1. Much more easier to work with, like that. Okay. So now you're trying to find out how many numbers of this pattern did we add up to end up with 98301. We want to find out how many terms of this pattern have we added up. So I want you to notice something, that this is still part of this pattern, isn't it? It's still part of this pattern. So meaning that you have a 3, 6, 12 as part of this. So if I change p to 1 there, you'll see that the first term will be just 3. Okay? It will be just 3. Because here you have 2 to the power 1. This cancels that. Then it means that the first term there would be 3. And for the second term, it would be 6, because now you're going to have 2 to the power 2. Then one of the 2's here is removed by this 2 in the denominator. Then 3 times 2 gives you that's 6. So don't be confused if this does not look like what you have written up there. It's basically the same thing. Okay, now let us go on. So now we had 908 at the side. Sorry, I think we had 98301. 98301 equal to, what is the value of A? We got 3 there. And the value of R that we have there is 2 to the power k, because we're looking for the value of k that will give us that sum, minus 1, like that, all over 2 minus 1. Okay, so now 2 minus 1 is just 1, and we have to divide both sides by 3. So we're going to have 98301 divided by 3 is equals to 2 to the power k minus 1, like that. Okay, and now we can take this one to that other side. So we have 98301 all over 3 plus 1 is equals to 2 to the power k. And now what are we going to have them? What should be our value in this case? If you punch in your calculator, you will see that you're going to get a value of 32.768, like that. So now I can just quickly go to logs, utilize logs, right? Because I'm solving for an unknown, which is the exponent there. So I'm going to say, well, k is equals to log of base 2. Then I take in that as my argument, which is 32768. So now when you punch that into the calculator, you'll see that the value of k that you're going to obtain is going to be 15, like that. So in this case, since k was the number of terms, it means that you have added 15 terms of that pattern above to obtain 98301 as a sum. Excellent. Now let us go on. Okay. So we have the other question, 3 point. Let me just go back up quickly. We have 3.2. So we're given a statement here. A geometric sequence and an arithmetic have the same first term here. So we'll keep track of this information. And we are also told that the common ratio of the geometric sequence is 1/3. The common difference of the arithmetic is 3. The sum of 22 terms of the arithmetic series is 734 more than the sum to infinity of the geometric series term. So these other parts here are easy to catch, right? Maybe the trick could be here on bullet point number 3, where they're saying 734 more than, right? So please here, they're not saying that you have to multiply, right? They do not say 734 times larger, okay? They just said more than. So meaning that instead of multiplication here, this is going to be simple addition, right? So for you to find the arithmetic series of 22 terms, right, as n of 22 terms, you just have to take the sum to infinity of the geometric and add 734 to it. That would give you that part, okay? So we're told that both terms, or both patterns rather, have the first value of A, like that, okay? So now what do they want? Calculate the first term. In this case, they just want us to calculate the value of A, right? So now let's just put that down on paper. Now, remember that for the geometric, this is the information we had. For the geometric, we had T1, right? But we do not know the value of T1, so we can just let it be A, like that. And we were also given that R, which is the constant ratio, is 1/3. Okay. And we would be calculating the sum to infinity here. And we're also given that for the arithmetic, we had T1, which is also A. So these two are the same. These two are the same. So let's just write it like that there. So these two are the same. Okay. Now we're also given that the difference for this guy here, the arithmetic, would be 3. Now we have to change bullet point number 3 into a formula, right? Into a formula. So we're given the information that S22, in this case, this would be the arithmetic, is equal to S to infinity. We know that We calculate for infinities whenever we're dealing with the geometric, in this case, plus 784 like that. Because they said that it's 734 more. Okay. So what should we do here? Now we have to develop the equation because everything is going to be answered by this guy here. Everything is going to be answered by that guy. And these here would be the other details that we have to consider. So now we know that for an arithmetic series, we're going to have 2a plus n minus 1 multiplied by the difference, close. And here we have how much? We have a over 1 minus r plus 734, like that. Okay, so now whenever you're looking for n, remember that they told us that it's 22 terms that gives us this information. We have 2a here, and here we have 22 minus 1 multiplied by 3, close like that. And here we have a, we do not know the value of a, that's what we're looking for, 1 minus, and here we were given that r is 1/3. And here we have 784. Okay, so now this is the part where you have to play with your math skills. It's nothing hectic, right? So you can just multiply through, break the brackets wherever you have to break the brackets, and then we can combine like terms like that. So if I multiply out into the bracket with 22 over 2 here, you'll see that here I'll end up with 22a plus, and then this solves, this will become 693. And this side here, if I solve the denominator, I will have 1 minus 1/3, which is going to give us 2/3. And then now 8 divided by 2/3, that will simplify to 3a over 2 like that. Okay, plus 734. Now this is basic math, right? Take this number to that side, take this one to the other side. Now you're going to have 22a minus 3a over 2, which is the same as 1.5. And you have 734 this side minus 693, like that. And what are you going to have here? So this will be 20.5. 20.5. A, and this side we're going to have a 41 like that, right? So now you're looking for a, so best thing to do is divide both sides by that 20.5, and you find that your value here of a is going to be what? It's going to be 2. So therefore, T1 is equals to 2. Done. Okay. Thank you for sticking around. And that is question 3. More videos coming in, and I will see you soon. Cheers.